Okay, in the previous session, we discussed about the definition of logically valid argument, and I showed you a set of argument which was logically valid. At the same time, I showed you an argument which was not logically valid. And I told you that a set of argument is called logically valid argument when the truth value of the argument are all true. Otherwise, this is not a logically valid argument. And to make you understand the meaning of that, I gave you an example where I considered the following two statements. The number of statements considered were only two, and we could very easily find out the chart having the truth values. But also I told you in the previous session that if the number of statements in my set of arguments increase, then it becomes tedious for us to find out the truth value. We can do it, but it becomes actually hectic. Now, to reduce this particular pressure, what we need to do is that we need to know some certain set of formula. And if these formula are known to us, and if you can understand the meaning of those formula, then if we are given a long set of arguments, in this case, what we'll try to do is that we try to find out, we try to look for those set of formulas, and this set of formula are actually found to be tautology in every situation. So we can directly conclude that, yeah, it is a tautology. So it is this particular part of the problem is a tautology. So let's get into the next part, and let's get into the next part, and let's get into the next part, and so on. In this way, we can reduce our effort of solving a particular problem. The first argument, which I actually proved to be logically valid argument, and which is the part of the set of formula, was known as modus ponens, and which is a Latin word which means method of affirming, and which was like this: when P implies Q and P, then we can conclude that Q is true. So this is one formula. Let us try to know what the other formula are. The next argument we have, P implies Q, not Q, and therefore not P. So let us quickly try to find out whether this particular set of statements in the argument are having the truth value true or not. Okay, the final statement is true or not. So let us try to find this out. So we will put the values first of all. P and Q are the original statements. P implies Q we need. Okay, and because you know that this is your A1, and for two statements, the total number of pairs will be 2 square, that is 2 to the power, that is 4. So we are going to put it over here: TT, TF, FT, and FF. And P implies Q will be, consequently, the P implies Q will be T, T, F, and T. Why it is F? Because, oh no, sorry, I have written the opposite, just the opposite of the. This is the hypothesis, this is the conclusion. So hypothesis is true, but the conclusion is false. So this will be the false statement. And this is here, hypothesis is false and conclusion is true. So this will be true. Okay. Then we need to find out the truth value of negation of the statement Q, and also the truth value of the negation of the statement P. So let us try to find it out. The negation of Q means when Q is true, it will be false. When Q is false, it will be true. So we have T. So here it will be F. For F, it will be T. For T, it will be F. For F, it will be T. Similarly, for T, it will be F. For T, it will be F. For F, it will be T. And for F, it will be T. Okay. Now, according to the argument, what do we need to find? We need to find the sixth column, which is P implies Q and not Q. Because you know that it is your A2 and we need to find A1 and A2. Okay. So P implies Q means this one and not Q means this one. Now for AND, both of them have to be true, otherwise it is false. So obviously this will be false because it is true, but that is false. This will be false because it is false and it is true. Here also it is false. And the last one is true. And lastly, we need to find A1, A2, A1 and A2 implies, suppose this is my A3, A3. So you need to find this. That means we need to check the truth value of this argument. Okay. Now you see, now according to this, this particular part has become the hypothesis. This is your hypothesis. And the conclusion is which one? Not P is the conclusion. So this is your conclusion. Okay. So therefore, according to that, let us try to find out the truth value. Since it is false, hypothesis is false and conclusion is false. So the truth value will be capital T. Hypothesis is false, conclusion is false. Truth value is capital T. Hypothesis is false, conclusion is true. Truth value is capital T. Both of them are true. Truth value is capital T, and therefore it is a tautology. So we have actually proved the second formula, and therefore it is a logically valid argument. This argument is a logically valid argument. And this argument has also a special name. Its name is, the argument's name is modus tollens, or method of denying. Method of denying. Let us try to find out, according to this argument and my example, which I have set, what does it imply actually? Now see, P implies Q means that X has got 2 doses of COVID covaxin, means X has got 2 doses of covaxin, implies his chance of not acquiring the virus is 80%. Not Q implies means Q is the statement that his chance of not acquiring the virus is 80%. So not Q means his chance is more than his chance of acquiring the disease is not 80%, therefore together they imply that not P, which means X has not taken 2 doses of Covaxin. Maybe he has got only 1 shot, or maybe he has not taken any shot at all. So just try to look at my arguments which I've made. If you find any problem, or if I have done any mistake, you can point it out by writing in the chat box. Otherwise, I have just tried to check whether my modus tollens, actually I have tried to verify my verify the argument modus tollens with my example which I have set over here. Okay, there is one particular here is one mistake which I must rectify. His chance of the word not will be there. His chance of not acquiring the disease is not 80%, because if you consider this to be your capital A, this is event capital A. Sorry, if this is event capital, from the probabilities point of view, this is event capital A, its complementary event A bar will be having this statement. That means what? If he gets 2 doses of Covaxin, then his chance of acquiring the not acquiring the disease actually increases by 80%. But if he has not taken the doses, his chance of acquiring the disease is not 80%. Okay, so therefore the second set of argument is actually a valid set of argument, which is called modus tollens. Now, in this manner, the other set of arguments can also be justified from this by keeping this particular example in mind. I am giving you another set of argument. You don't have to do many things. Just try to check whether this set of argument is valid or not. The next example which I'm going to give you is argument 3, which goes like this. It has 2 parts. Part A consists of the following statements: P or Q and not P concludes Q. And the part B says P or Q and not Q concludes P. So I'm asking all the students to quickly check whether this set of argument is logically valid or not. And if it is, then please write in the chat box. Okay, so I'm waiting for your replies. If any one of you give me the answer by writing in the chat box that yes, it is a valid set of arguments, then I am going to give you the name of this argument. Okay, if this particular argument has another name. So please try to do it by yourself and check whether it is a valid set of argument or not. Some of the students can try with A and some of the students can try with B. So I'm waiting for your reply. Okay, so it's very, what should I say? I shouldn't say that it is a wonderful situation, but I'm just thinking that, okay, a particular situation, the point is that a particular situation can be verified from different angles, from different perspectives. Okay, so that is happening over here. Now, 2 students have already written it is a valid set of arguments, and you can easily check that small b is also a valid set of argument. So such an argument is actually known as disjunctive syllogisms. Disjunctive syllogisms. Okay. Now I'm going to give you another argument, which is quite pretty obvious. You don't have to check it because we know it very well, and we are pretty much sure that it happens. It is going to happen always. Suppose we have three statements. P, Q, R. The argument is designed as follows. The argument is designed as follows. P implies Q, Q implies R, therefore P implies R. This type of argument we are familiar with. We have often applied it in various topics, even in our school days also. You don't have to check whether it is a valid or not. It is indeed a valid argument. Its name is hypothetical syllogism. If you have time, if you want, you can verify this quickly later on. So this is my argument 4. Argument 5, which I'm going to write here, that I'll ask you to check once again, because it is a new and a little bit of confusing argument. Argument 5 goes like this, and I'm going to discuss on argument 5 if you can find that this argument is valid. Again here, we are considering three set of statements. For PQR statements, the argument is defined as follows. P or Q, P implies R, Q implies R, therefore R. Just check whether this argument is a valid argument or not. And you have already known that if we have n statements, total number of n tuples will be 2 to the power n with capital T and capital F. So for 3 statements, the total number of triplets or total number of rows will be 8. Okay, now you design the table. It will take some of your time. You design this table, truth table, and try to check whether this argument 5 is valid or not. Once you find it, then I'm going to give you the name of this particular argument, and we are going to justify the scenario with respect to an example. Okay, I am also trying to do it from my end, and those who are not finding it comfortable to make charts, they can also take the help from my calculation, and those who are doing the calculation, they can check whether they are doing it right or not. Now we have 3 sets of arguments. Let us try to put all the values, possible values. So what is the way by which we can put it over here? We already know that there will be 8 triplets, 8 number of rows. So we'll just put 4 T's for the statement P and 4 F's for the statement F, for the statement P. For this set of T, we will put TT, TF, FT, and FF. For this set, we put FF, FT, or let us write TF, or it would be nice if I write the particular pattern will be maintained. FT, TF, and TT. Now, what do we need? First of all, we need P or Q. P or Q, that means we need to check these two. And P or Q is true only if at least one of them is true. So, for the first case, we get capital T. For the second one, we get capital T. For the third one, we get how much? Capital T, isn't it? If at least one of them is true, then it is true. For third one, we get capital T. And for fourth one, we get capital T. Both of them are false, so we get false. Both of them are false, so we get false. At least one of them is true, so we get T. At least one of them is true, so we get T. Just check whether my table for P or Q is right or wrong. Just check it. So it will be cross-verified. Oh, Antara Kumari has already done it. Antara, if I have done the column P or Q correctly, then you can tell me whether it is all the things are correct or not. Since I have already started doing this particular problem, so let us try to finish it. Okay, P implies R means I am going to check these two now. P implies R means hypothesis is true, conclusion is true, so this will be true. Hypothesis is true, conclusion is false, so this will be false. Hypothesis true, conclusion true, it will be true. Hypothesis true, conclusion false, so it will be false. Hypothesis false, conclusion false, so this will be true. Hypothesis false, conclusion true, it will be true. Hypothesis false, conclusion false, true. Hypothesis false, conclusion true, so it will be true. Q implies R means I need to check these two now. So hypothesis true, conclusion true, so we have true. Hypothesis true, conclusion false, so it is false. Hypothesis false, conclusion true, so it is true. Hypothesis false, conclusion false, true. Hypothesis false, conclusion false, true. Hypothesis false, conclusion true, true. Hypothesis true, conclusion false, false. Hypothesis true, conclusion true, so true. Okay, and then we have found P or Q and P implies R. Okay, and what do we need to find out here? First of all, what we need to check? Let us try to understand that. So suppose this is my A1, this is my A2, this is my A3, and this is my A4. So actually we need to check A1 and A2 and A3. This implies A4. This has to be checked. So first of all, we'll find out P or Q and P implies R. So let us try to find it out. P or Q and P implies R. Okay, so both of them are true. So in this case, it is true. Here one is false, so this will be false. Both of them are true, so it will be true. One is false, so it is false. In both the two cases, it will be false. And for the last two cases, it will be true. Now we have found this. Next, so we have found this particular section. A1 and A2 has been found. Now, since we can name it as, say, for example, we can name it as A prime. Now we are going to test A prime and A3. So let us try to find. So next chart will be P or Q and P implies R and Q implies R. So we need to consider these two columns. So both of them are true. So it is true. Here it will be false. The next one will be true. The fourth one will be false. The fifth one will be false. The sixth one will be false. The seventh one will be false. The last one will be true. And then lastly, we are going to find what we actually need to find. So it will be P or Q and P implies R and Q implies R. Together, they imply R. Okay, so we have to consider this column now. This column is my conclusion column, and this column is my hypothesis column. So let us check. Hypothesis is true, conclusion is true. Hypothesis is false, conclusion is false. Hypothesis is true, conclusion is true. Hypothesis is false, conclusion is false. Hypothesis is false, conclusion is false. Hypothesis is false, conclusion is true. Hypothesis is false, conclusion is false. Hypothesis is true, conclusion is true. And we find that this is a tautology. So therefore, the argument P or Q, P implies R, Q implies R, together imply R. This is a valid argument, and this argument is known as, such an argument is known as dilemma. This argument is known as dilemma. Now, to understand this with an example, you consider the following statements. I am just giving you the statement. Okay. So just you check by yourself. My statements are, suppose I am writing P to be the person has been vaccinated by Covaxin. Statement number Q is the person has been vaccinated by Covishield. Number R, the statement R is the chance of acquiring COVID-19 reduced by 70%. So these are my statements. So what this set of arguments was telling, P or Q, then we have P implies R, then we have Q implies R, their conclusion is R. So what does it mean? Now read it out. P or Q means, I'm saying the person, the so-called person has been vaccinated either by the Covaxin or by Covishield. P implies R means, if the person has been vaccinated by Covaxin, then the chance of acquiring COVID-19 reduced by 70%. Q implies R means, if the person has been vaccinated by Covishield, the chance of acquiring COVID-19 reduced by 70%. If I now take all the statements together into consideration, that means the chance of acquiring COVID-19 by the person is actually been reduced by 70%, because either he has been vaccinated by Covaxin, or he has been vaccinated by Covishield. Now the people are fighting with each other, governments are fighting with each other, people are confused, marketing analysts are confused, which vaccine is better, Covishield is better or Covaxin is better. Now you have done this mathematics. Now you students, you try to find out by yourself, you try to think what is your conclusion, which particular do you want to go with a dilemma. I mean, this particular set of argument is called dilemma. Why is it called dilemma? It is because then if the person, now the dilemma is everybody, all of us are actually having the dilemma. What sort of dilemma we are having? The dilemma is people are saying, the scientists are saying that if you get vaccinated by Covaxin, then your chance of acquiring the disease reduced by 70%. If you get Covishield, then also your chance reduced. Oh, people are saying that if you get Covaxin, your chance reduced by 80%. If you get Covishield, your chance reduced by 70%. Okay, now if I want to reduce my chance of acquiring the disease by 70%, shall I go for Covishield or shall I go for Covaxin? We people have to decide it by ourselves. That is the dilemma which is in front of us. Okay. Now we have less time. The class is going to end. And this is going to be the last session of my today's class. Tomorrow we are going to discuss further on this particular topic. Before the class ends, I am going to give you two more set of arguments. Not two actually, three more set of arguments, which you can very well easily. What was the serial number of the argument that I gave you? 5. So we have 6, 7, 8. So argument 6, sorry, this is not example. Argument 6, argument 7, and argument 8 can be verified by you quickly. You can do it by yourself, okay? And you can discuss this particular, your finding, you can compare your finding by making statements. So the part A of argument 6 gives you if P and Q, conclusion is P. Part B is saying if P and Q, conclusion is Q. Okay. So this particular set of argument is called conjunctive simplification. Argument 7 is saying it has also two parts. If we have the statement P, then a conclusion is P or Q. If you have a statement Q, the conclusion is P or Q. These are simple arguments. You can test it by yourself. It is called disjunctive additions. And lastly, we have argument 8, which goes like this. If we have statement P and we have statement Q, the conclusion is P and Q. This is called conjunctive addition. These are simple set of these are last three arguments, argument 6, 7, and 8. These are simple set of arguments. And without making the truth table of that, we can very well say directly that, yeah, it is going to happen. This happens. Okay. The most important set of arguments in this particular case that I discussed was actually the first 5 arguments. You have to remember them always. Okay. In fact, you have to remember all the set of arguments, 8 arguments. for doing problems. These are actually the theorems. These are actually the formulas which you have proved just now and justified on the basis of a particular example. Tomorrow, I'm going to show you an example in which this formula can be used to judge whether the set of arguments which I'll be dealing with is logically valid or not. So today you you practice it at home and make your own statements and try to verify the things. If you have any sort of argument with your friends, okay, put it down in your copy, his argument, your statement, his statement, and try to justify what's happening, what should be the conclusion, who is logically valid and who is not. So with this, I'm going to conclude my today's session. Thank you. We are going to meet tomorrow in the scheduled time.